Hello there. This video is about my Physics 101 lab project experiment, where I will derive Earth's gravitational acceleration with a simple pendulum. Now let me explain to you my experiment. So the following diagram you can see shows how a pendulum is. A pendulum is a system composing of a pivoting point, a string, and a massive bob. As you can see, the massive bob can be displaced a certain amount, then the restoring force, that is gravity, will take the bob towards the equilibrium point and then past it, taking the system into a state of oscillation, periodic oscillations. Now you can see an equation showing how the period is affected by the pendulum's string length and the gravitational acceleration. And when we square the left-hand side and the right-hand side of the equation, we get t squared equals 4 pi squared times length over g. So if we graph this equation by t squared versus L, you can see that it becomes linearized, where 4 pi squared over g is the slope of the graph. Thus, I will calculate the period values for differing length values in my pendulum setup. Thus, by linearizing the data I have collected, by squaring the periods I have measured, thus graphing the data, I will find a linear graph where the slope of the graph will be 4 pi squared over g. Then, when then by some algebraical manipulation, we can see that the g can be calculated by, dividing 4 pi squared by the measured value of the slope of the graph. Now my experimental setup consists of this pendulum setup, which is composed of a string attached to the ceiling, which has an initial length of 2.6 meters, which is attached to a massive bob of 50 grams. On the ground I have marked the equilibrium position, which is 0 degrees, and the position where the angle is 15 degrees. Now when I take the string and face the bob towards the 15 degrees, then it will be let down from a 15 degree angle. The same will go for shorter string lengths, but when doing so, it isn't just enough to letting down from this position, but the angle must be checked. So I also have a handy protractor to measure the angle which I am letting the string. So thus, when I take the string and place the bob to the 15 degree angle, and when I release the bob, I will start the timer and measure for 5 oscillations. When the 5 oscillations have finished, I will stop the timer and write down my data and continue doing so for 2.6 meters and gradually decreasing 20 centimeters. Okay, so according to the equation I have provided, if we plot the data from t squared against the L string length, we will get a linear graph, as I said, and we got a linear graph. In fact, the graph we have plotted has an Pearson coefficient of 0.9993, which is surprisingly high. I myself don't know what to say. It is a very good result regarding my elementary setup. So I am really happy with the results. And from the linear graph, from the best fit line, we can see slope of 3.975, and well, from this value we'll calculate the g value. Okay, so to calculate our g value, we knew from the start that g was equal to 4 pi squared over our slope of the best fit line, which that would be 4 pi squared over 3.975, which was our slope value. And when we do the calculation, it comes to approximately 9.31 meters per second squared. Now, 9.31 meters per second squared is remarkably close to the real value of g at Ankara, which is around 9.7. I had calculated it in my report. I don't know it by heart, but it is remarkably close to, well, 1 decimal point. Thus, I think our experiment was generally can be considered generally as a success. So thank you for watching.